1, 2. Next, A, B, 3, 4. Next, C, D, 1, 2. Then C, D, 3, 4. This is the Cartesian product. Okay? One important thing when you are using the Cartesian product in real life system, in SQL later, do not use the Cartesian product frequently. Sometimes you need to use. Why? It's a combination. How many tuples? N number of tuples. How many? N times N number of tuples will return. Think about it. You have 1 million of customers. You have 10,000 branches. How many Cartesian product? 10,000 of million. So because of that, sometimes your system is very, very slow. Okay? When you test something very complicated SQL, sometimes you may not realize whether your SQL include the Cartesian product or not. We will see why later. So, however, in case you have the Cartesian product, it will combine all together. So tons of billions of data will be processed. That consume the memory, that consume the I/O, that consume the network bandwidth. So your system will be degraded. Okay, so that's the Cartesian product. So be careful, it will return the I times S, the tuples will be returned. Does it require the type comparable? Cartesian product? No. Because it's all combination. As you can see, A, B, C, D. There's no comparison. So you can just add up a number of columns. So it does not require type comparable. Okay, so this is an example of the Cartesian product. So what does it mean? We have the female employee. We have the names of female employee, then what the Cartesian product with the dependent. It will return huge amount of data, as you can see. So for example, how many female? We have 3. However, how many dependent? We have 1, 2, 3, 4, 5, 6, 7, 8 dependent. Okay? So for each female, the employee, for example, Alicia is combined with all this. And Jennifer and all this. And also all these 4 choices. It will return 24 tuples. Okay? This is a Cartesian product. But sometimes you need to use such a Cartesian product in your SQL. It's a little bit high level. Okay? If you cannot solve the problem with the join operation that we are going to learn, the time you need to use such a Cartesian product. Then next, the join operation. How many of you heard about the join operation? Join in SQL. What do you feel about the join operation? Connect. Okay? Its name implies join. Connect. Have you ever heard about the same name of operation in other languages, other data structure? No. Only relational database has a join operation. Why? Why we need to connect? Why we need to join?
So we should get the data from 2 tables.
Yes? Data
From 2 tables,
two different tables, yes.
we get the data from 2 different tables.
Two different tables, same thing. Why? We need to get the data from 2 different tables.
We only require data. Only require data from 2 tables.
One of the goal of, yes.
A common use of the join is to get like an author from, like get the relationship of something that's related to
Yes.
maybe.
So your information architecture, right? Because we make the relation by something meaning. Like this relation is for employee only. This relation only for department only. However, user want to access department information as well as employee information. Because one of the important things when you design the database, you should get rid of what? Redundant information. We really feel as a database designer, as a database administrator, database guys, we really hate such a redundant information. Redundant information causes problem. What kind of problem? Waste of space, definitely. And
one might be updated, but not all of them.
yes, which means when you, for example, if my information is everywhere or each department, I should inform. Whenever I move into new house, I should inform department of HR, payroll office. You should inform. It's very hard to maintain constraint. Okay. What was the main question? Oh, why? What's the main problem of such a redundant information? It's a very hard to manage database constraint. Okay? Because of that, we try to remove such a redundant information as much as possible, as less redundant information as possible. However, that causes the problem of accessing the data. Nobody wants to access only the customer information only. Customers activity, customers transaction, customers other information. At the time, no way. We need to combine. At the time, we need join operation to access multiple database source, which means relation. You think join is, yes, join is one of the unique operations that represent the characteristic of the relational database. However, join is the most expensive operation in database. What does that mean? Expensive. Takes a time. Also, it requires more resource. First, memory. When you join two tables, definitely you need memory space. We will see in query processing later why we need the memory. Also, you need to access the table, multiple tables same time. Okay? If you do not have very nice this controller, it will be bottleneck. Also, in combat, we have one room and there are a lot of in and out. So if we separate the two rooms, if we read the different door, yes, it's okay. However, sometimes one door and two different rooms, it will be bottleneck because you need to access multiple data source relations. So join is not good for performance, database performance. Okay, so you should be careful. That's the reason later we will discuss about why don't we combine the department and employee together. Even though we lose redundancy, we have the redundant information, we can combine. That is called denormalization, which is combine them together. Anyway, so join operation is to combine the tuples from the multiple sources. How can we use? We will use. Is there any specific name of this? I know where it comes from. It comes from Cartesian product. Why? Join operation starts from the Cartesian product. Okay? Then it limits certain tuples. Okay? For example, we have one more. C. This C is for, let's say D. D. So this is the 1, 1, 2, 2. This is a Cartesian product of R1 and R2, but I need the tuple whose D and C are same. Okay, think about this is D and O. This is a D number. They are same. Check. From Cartesian product. 1, 1. This is the same. Okay. 1, 3. So this is not. 2, 1. No. And 2, 3. No. So in this case, this will be returned. How can we do that? R1, R2, then select D equals C. You see D, E equals C. Does it make sense? Yes, this is actually join. So join symbol comes from Cartesian product, but anyway, we need to differentiate from the symbol and this one. It looks like butterfly, or ribbon, whatever. Is there any specific name? Seriously. Everybody say just join operation. So this is the join operation. Join operation consists of two relations and with join condition. What is this join condition? Join condition is select condition of Cartesian order. Okay, so let's take a look at the example of this one. What is the example? This example is the same as realistic theory in your case 1, right? So suppose that we want to retrieve the name of manager of each department. Can you get that information from one relation? For example, employee. Employee provide name, but not manager information. What about department relation? Department provide manager information, manager SSN. However, it does not have name information. If you are not sure, why don't you take a look at your handout. Okay? It has the sample data. So we cannot get this information from one. So definitely we need to access employee for name and department for manager information. How can we do that? Using join operation. Join operation, we can access the employee and department. And join condition. What can be the join condition? At that time, you can take a look at your database schema diagram. If you take a look at the database schema diagram, department, manager, social security number. We need name of this. However, this manager, how can you get the name of manager? First, you need to take a look at the manager social security number. For example, 111. Then take a look at the employee, 111, get the name, right? This is the foreign key. So, we need to check whether SSN is equal to manager social security number. That is SSN equal to MGR SSN over here. That's it. Right? The time. What if somebody may use SSN for this? No problem. Right? You can name as you want. SSN is equal to SSN. It's very hard to recognize which one is which. That time you can use employee not SSN equal to department not SSN. In this case, MGR SSN. To make sure we learn how to represent the attribute. Relation name dot attribute name. You can use the full name of that. So, join operation, there's a join operation. Okay, so in this case, the output is department, doesn't matter which one is which. However, it will be the different later. But so far, there's no problem. Department and employee join with the MGR social security number. If you are using the database schema diagram, it will like this. All department and all employee check manager social security number and social security number, they are same. What if I want to retrieve only the name? As you can name. You can use project, last name, first name, middle name, initial in front of this. Okay. Any questions so far? There are different types of join operation. The main concept is the same. Join combine two table, two relation with a Cartesian product as well as join condition. Join condition is the select condition. Okay, then first equijoin. Equijoin means in join condition it will use only equality, which is the most popular in join operation. Most of join condition actually equality. What about inequality? What about other? Yes, that works also. However, most of it, because due to the nature of join operation, why we need the join operation? We try to limit the data from Cartesian product. Equijoin is the most popular. Not always, you can use the even inequality. That is equijoin. Next, natural join. Whether or not you realize, when you join two relations, you need to find common information, like for example, department manager's name. How can you find the department manager's name? Their social security number should exist here, right? And they should be what? Same. How can you preserve such a same information? Using the differential integrity. Foreign key. So whenever new manager is inserted, updated, you need to check whether he or she is the employee. How? Using foreign key. Okay? Or department manager, or the supervisor. Supervisor, you need to check whether that supervisor is employed or not. How did you check? Using supervisor is foreign key. Okay? So most of case, such a join condition should exist as foreign key operation. Okay? Sometimes such a foreign key, okay, they use the same name, like the SSN. It's the same name. Also, D number is the D number, same name. In case the same name of attribute automatically join. Such a same name of attribute for join condition. That is called natural join. Naturally join because they are the same. Automatically join. Okay? Which is not very popular. Okay? Because it's too much risk. Very specific case. Many of the database actually they do not use the same attribute. Even we make the different name to differentiate SSN and MGR SSN, right? However, when Dr. E.F. Code proposed this relational model, he believed this one naturally same, so naturally join. But it is not popular in real DBMS system. But it is still used in the DBMS as the natural join. Okay, This is the example of the natural join. So for the natural join, we don't need the join condition. That doesn't mean there is no join condition. The join condition is automatically considered as the same name of attribute. For example, in this case, so we have the department, natural join with the department location, okay? Which means we have the D number, manager social security number is the same. So it will be automatically joined with the manager social security number. Complete set of relational operation means using select, project, union, set, difference, and Cartesian product, we can make other operation. Is there any join operation here? No, but you can make the join operation using select and Cartesian product. What about the intersection? No intersection by intersection may be possible using these 5 basic fundamental operations. That is called complete set of the relational operation. Whether or not you realize you run such a complete set of operation in Edge browser. Next, division. I think the last one. Division. This is kind of a divide. However, there is no divisible in set operation. Instead, in relational operation, division means we write, if we divide SSN PNOs divided by PNO, we write to get the add tuples from here. That includes both all of the denominator. Okay, which means we try to check whether ESSN, same ESSN include PNO. Should be the same. 1, 2, yes, this is okay. What about the 6688444? It has only PNO3. PNO3 not. So this is not. 453, 453, 1, 453, 453, yes. So this is okay. 333, 4455, 2, 3. There's no 1. So this is not. 999, 8877, no. So this time, the return of this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 4, 5, 3, 4, 5, 3, 4, 5, 3. That includes all of tuples in denominator. Okay? So division is not actually division in your math. Okay? Division means, so we try to return all tuples that include all the denominator. Okay? At this time, what is the attribute? Attribute is without this minus. So set of attribute of nominator minus set of denominator. That is the SSN. This is a division. On my example here, so in this case, R minus S means output is definitely R minus A, B minus A, so it's a B. Okay, so we need to check all B, whether that includes A1, A2, A3. B1 includes all over 3. Yes, so B1 is returned. B2, B2, A1 and A3 only, so B2 is not. B3, there's no A1, so not. B4, A1, A2, A3, so B4 is returned like this. B1, B4. However, that division was proposed first time, not much used in real DBMS system. Why? It takes too long time in the system. Okay? If you need such an operation, you can implement using other operations. Also, you can get the help of your host language, not database language, to increase the performance. So division is not actually practically used in the commercial DBMS system, but you do better know the concept of division. So this is a summary of the operation that we have discussed so far. Next class we will continue for function, aggregate function. That's one of the benefits of using SQL, the relational operation, the aggregate function, as well as for secret language final. Okay, any question? Okay, thank you and see you next week. There was a homework. Before I forget, I will give the homework the next class. So you have homework by the coming Tuesday, right? That is the last week.